Hi everybody, these are our answers for our chemistry practice test, and the multiple choice questions, you guys are going to see that they all look very similar. They give you some repeating groups and they use colors on the repeating groups to tell you what the atoms are. And they don't really tell you the specific atoms, they just want you to know that a yellow one is a different atom than a green one, that is a different atom than a blue one. So you have to think of each color as representing a different atom. Also, if you struggled with this without opening this, the practice test would have been very hard just in print because these colors did not come out, and you will have colors when you take the test. At any rate, they've got in the box here the repeating group of atoms. And remember, a repeating group of atoms means a molecule. And when we have a repeating group of atoms that changes, that means the molecule is different. That means the properties will be different. So before we even read any of the question, we just need to identify that we're looking at two different molecules because we have two different sets of atoms here. So the question is the diagram above shows the group of atoms that repeat to make two samples, sample 1 and sample 2 are both gases at room temperature. Will the other properties be the same or will they be different? And they give you some examples of properties. So we've talked a lot about how every time we get a new repeating group, it makes a new molecule and has their own properties. So the properties will be different. And if you go down to the choices, there's only two of them that say that the properties are going to be different. That's going to be B, and that is going to be A and B. So A says the other properties will be different because the repeating groups of atoms in each sample are made of different types of atoms. That is the correct answer. These are different atoms than these. B says the other properties will be different because there's more of the group. And they're trying to throw you off in the picture here by having more molecules here than here. But remember, the number of molecules doesn't change the properties of it. If you have a glass of water, it's got the same properties as a gallon of water. But again, watch for these changes in combination. Okay, our next question. Now the next question, before we even read it, look what you've got in the picture. You've got the reactants over here, and it says it smells irritating and that it's a black solid with no smell. On here, it says it's a yellow solid with a sweet smell. If the properties change, it means these are got to be different from these right here. That's something we need to look at before we even look at the question. Damien mixed two samples together, a red liquid that smells irritating and a black solid with no smell. He analyzed the results and found two ending substances. One of the ending substances was a yellow solid. This ending substance is made up of repeating groups of atoms shown above. Which of the diagrams to the left shows the two groups of atoms in the samples Damien could have mixed together? So the key is on here, we don't create or destroy atoms, and the colors here represent distinct atoms. That means that over here in our reactants, we've got to have a green atom, which would be one kind, a dark blue, and this kind of brown. Right here, it can't be this because we do not have any brown atoms at all. We have a green and a blue, but no brown. So you're just kind of following the colors. On sample 2, we have a dark blue, a green, and a brown. We have everything we need to make that. So that's looking like B is our answer. If we go to C, we have, we're looking for blue, brown, and green. And if here we go here, and we don't have any brown, so it can't be C. And right here, notice they're showing blue, brown, and green, and you might go, oh, that's it. But remember, the properties change, so the atoms or the molecules change. These right here are the exact same molecules as those right there. That would be a physical change, and we already know it's a chemical change because it said the properties change. So that leads us to B is the only possible one that is a different substance over here than here and has all of the required atoms that we need. Moving on to our final one. This one here, we're given the reactants and not the substances. We really don't have any information here, So now we do have to read this. And this one's got a little tricky piece. It says, Patrick works at a company that makes paper and needs a chemical to make the paper brighter. To do this, he mixed two colorless substances together in a container. The diagram above shows the repeating groups of atoms of the two starting substances. After mixing, Patrick analyzed the sample in a sealed container so nothing could escape. Notice he is working with a closed system. It says he found two white substances. Each of the diagrams to the left shows the two groups of atoms at the ending substances. Now there's a couple of really important things here. One, he got a change in color, which means these substances can't be the same as these. We've got a chemical change, so those need to rearrange. The other important thing is it's a sealed container. So in the sealed container, no atoms are going to get created or destroyed. That tells us that we have to not only have these over here, but we have to have the same number as those over there. So again, if we look at this now, this has got 2 blue. We don't have 2 blue right here. That goes away. We don't create atoms. The second one, we have a yellow and a blue, and we have a red and a red. We have 4 atoms here. 2 of them are red, 1 of them is yellow, 1 of them is blue. That is looking like the right answer for this. If we go here, now we have the exact same thing as we have up here. And since we know it changed color and it's a chemical change, once again, like the last question, that is not changed chemically. That would be a physical change. It's the same thing as we had before. So that's out. And then finally down here, notice we have 5 atoms here, and we're in a sealed container, and we need 4. So our answer, once again, is B. Very important on these multiple choices to determine, one, if a chemical change has taken place or not, and then realize we've got to have that we don't create atoms in a chemical change. We just move them around. So, and when we take the test, we will have colored versions up for you to see on this. So, those are really important, but there's a couple things to watch for, and you'll do just fine on them. Okay? So, take it away, Mrs. Brent.
All right, question number 4. When atoms rearrange into new repeating groups, remember repeating groups are repeating molecules, we have a chemical change. What else about them will change? We know that if our atoms are going to change, they're going to regroup. We have new repeating molecules, then the substance's properties are going to change. We'll have a new substance with new properties. Question number 5. Your friend says that when water melts, it is a chemical change. What would you say to your friend and provide evidence that you could give? If it's changing phase, we know that's a physical change. It's reversible. It's the substance is still water, but the important thing that we can link back to, we're not seeing any evidence that a chemical change occurred. There's no color change, there's no temperature change, there's no smell change. When we did vinegar and baking soda and we did our reaction in a bag, we saw these to show that a chemical change occurred. None of that changed up here, so we just have a physical change. Number 6. Sometimes when you put 2 substances together, they will react just by coming in contact, like vinegar and baking soda. Sometimes 2 substances need a little bit of help to react. Tell 2 things that can make a chemical change occur. Also tell what we call these kinds of things. First, we're going to name those kind of things, and we call that a catalyst. And a catalyst, remember, can cause a chemical change. Electricity, heat, water, those are all catalysts. We use those as lab conditions in our Amplify simulations to cause our chemical changes to occur. Number 7. In any chemical reaction, tell 1 fact that you know for sure about the reactants in the products as they change chemically. Tell how you know this. Hint, it is against the law not to know this. So this is going back to our law of conservation of mass. In any chemical reaction, the number of atoms put in, our reactants, must equal the number of atoms that come out, our product. Nothing can be created or destroyed. And Mr. Condit just showed that with our colored atoms. The number in has to equal the number out. And then number 8, How is a physical change different from a chemical change? A physical change is reversible and the substance has the same properties. Where a chemical change, it's not reversible. We have new substances with new properties. Those are our repeating groups or different repeating molecules. Number 9, why did only one of the steel, wool, and water systems gain mass? Only one of the steel, wool, and water systems gained mass because it was an open system where atoms could move in or out. And so we couldn't control the molecules that were entering or leaving.
Thanks for watching, everybody, and hope you do well on the test.